Welcome back. In the previous lecture, we looked into the concepts of class and objects. In this lecture, we'll look at some other concepts related to class design and implementation. At the end of this lecture, you will be able to develop a simple Java program using the commonly used programming constructs. And the constructs discussed in this lecture are the this keyword, static members, and the instance initializer block. Now, note that these concepts will be discussed with respect to the Java programming language, but most of the other object-oriented programming languages also have these concepts. So if you are using another programming language to learn object-oriented programming, you can simply search it up in the web to see how these constructs or concepts have been used in those languages. The first one, the this keyword. What is this keyword? So you might have noted this in the previous lecture as well when I was showing code. So as you can see here, in the construct of the monster class, we are using the keyword this in front of the two attributes, age and name. So here, the keyword this refers to the current instance of the class. If you look at this figure, the idea is more elaborated. So in this case, we have a monster class. As we learned last week, we can create different objects, monster objects from this class. We can create any number of objects from this monster class. So here I have created 3 objects, monster 1, monster 2, and monster 3. And monster 1 has age as 20 and name M1. Monster 2 has age 30 and name M2. And monster 3 has age 10, name M3. How do we create these objects? By calling the monster constructor with the new keyword. In other words, if you want to create the monster 3 object, what we do is we write monster, remember capital M because this is the class name, monster 3 equals new monster. Now, by calling this constructor in different places, we would have created multiple monster objects. And when we say this age, in the monster 1's case, this means age of the monster 1. In the monster 2 case, this dot age means the age of the monster 2. That means age 30. So in other words, this keyword refers to the attribute of the current object. So in other words, this within the monster 1 refers to the monster 1's attributes, and within the monster 2 object, it will refer to the monster 2's attribute. Now, if you look again in this full code, you can see the name of the attribute is age. We have private int age. And similarly, in the monster constructor, the parameters, incoming parameters are having the same name. So int age and string name, these names are similar to the attribute names we have used. Now, suppose that this keyword was not there, what would happen? Age equals age, name equals name. That is confusing to the compiler. So when you add the word this, it distinguishes this age, first age, the age that is in the left-hand side of the assignment. It is identified as the attribute. And the other one implicitly gets identified as the parameter value that comes in. So that is the first use of the keyword this. So this is what we have shown here in the first bullet point. We can use this keyword to differentiate between instance variable and local variable, or instance variable and the method parameters. Another usefulness of using this keyword is in constructor chaining. So if you remember last week, we looked at different ways of creating a constructor. A constructor that has no parameters, a constructor has some parameters, a constructor has multiple parameters. So in many object-oriented programming languages, for one class, we can provide multiple constructors. So that is to give more flexibility to those who are creating objects from that class. For example, a class that is creating monster objects, it can decide, okay, I'm going to create monster object without any parameter, and later I'm going to set the values. Or in some case, the monster object may be created by initializing all the parameters of the monster class. Or an intermediate state where the monster object is created with some of the parameters attributes initialized, and the rest will be set through maybe setters or some other methods. So that means for a given class there can be more than one constructor. Some constructors taking no parameters, some taking the parameters corresponding to all the attributes or corresponding to some of the attributes. In certain cases, for example, now if you look here, the first constructor that does not take any parameter, when it is being called, it won't set the object's values, the age and name values into a set of default values. In other words, here it wants to set the monster object's age to 10 and the name to A1. So how is it achieved? So now in this case, as you can see, there is a monster constructor that takes the age and name as the parameter. So the constructor that does not take any parameters sets the default values by calling the constructor that takes the parameters. So in order to connect these constructors, we can explicitly use the word this, because you can't use the word monster here, it will give an error, so you have to use the word this. So this means the constructor that takes an integer parameter and a string parameter. So the Java compiler can resolve this reference, the reference by this keyword to the monster constructor that takes an integer and a string as the input parameters. So another use of this keyword is to invoke current class method explicitly. Now remember, now for in this case, so we have the monster constructor and we have another method, the set details. So if you want, you can explicitly call the set details method by using the this keyword. However, remember here, even if this keyword is not there, that means if you just write set details within brackets 10 and A1, still the code will be correctly executed. But if you want to explicitly refer to a method, you can of course use this keyword. The good thing is, if you are using an IDE like Eclipse or NetBeans, the moment you type this and place the dot, all the class methods will be loaded. So you can, rather than having to type the method set details, you can simply select from that drop down and get the code. So that is one simple advantage of using this keyword in this calling the method of the same class. However, keep in mind, as I mentioned earlier, the set details method, that means a method within the class can be called by another constructor or a method without this keyword as well. And there are two other places where we can make use of this keyword. So the first one is when we have to pass the object as a parameter to some other method. For example, if you see here, for the warrior set monster method, we have to give a monster. So we have to give the current instance of the monster here. So what we do is we pass this keyword. That's all we write, this keyword, and the object corresponding to the current monster will be sent to this warrior object. The final one is to return the current instance of the class. For some method, for example, if it's a method called by some other class, we may want to send the current object that contains this send instance method. That means there's a monster class, it has the send instance method. When executed, that means when the objects are created from this monster class, when some other class calls the send instance method, the current each object will return itself, right? So there can be 10 objects created from the monster class. So if someone calls, so if I go back and discuss with this diagram, so suppose we have created monster 1, monster 2, and monster 3 objects. So for a method like getMonster that will return the monster object, if that method was executed on the monster 1 object, it will return the monster 1 object. If the method was called on the monster 2 object, the method will return the monster 2 object. Likewise, so it is again a very important use when we have to return the current object as in response to a method call. The next concept that I want to discuss is the static members. These are also known as class members. So, although you don't know static members, you know the other members in a class. So what are the other members in a class? The fields and methods, or attributes and methods. So, static members refer to the fields and methods, or attributes and methods, where the value is maintained across all the objects. The same value is maintained across all the objects. Now, what does this mean? Look at this example. Now, as you can see, we have again the monster class, okay, just the part of it, and we have two variables. We have the private int age, and we have the private static int monster count. As you can see, the first one doesn't have the static keyword, but the second one has. The one with the static keyword we call a static variable or a class variable. As opposed to that, our int age variable that does not have a static keyword, we call the instance variable or the instance attribute. So what is this? The static keyword and the associated attribute. So if you look at this example, again, we have a monster class and we are creating three objects: monster 1, monster 2, and monster 3. So for all the objects, or the monster 1, monster 2, monster 3 objects, monster count value will be the same. Why? Because it's a static variable. So that is the meaning of using the static keyword. If an integer is, if a variable is using the static keyword, it means the value of this variable or the attribute is same across all the objects created from that class. So that is what we have shown here. So here, although we have three objects, the value of the monster count attribute or the monster count static variable is the same. So all the three objects have the monster count as 3. As opposed to that, if you look at the instance variable, the age, for the monster 2, it has one value. For the monster 3, it has another value. And for the monster 1, it has another value. Right? I hope it is clear the difference between the static members and the non-static members. So again, to highlight and explain once more. So our variables, so the attributes can be of two types. One with the static and one without the static or the non-static. Static means, or we call it the static variables or class variables. The value of these variables will be same across all the objects created from this class. In contrast, the instance variable or the instance attribute will have the different values as per our logic for the different class, different objects. So that is the difference between static attributes and the instance attributes. So a very common use of the static members is to record the number of objects created. Now, if you look at this example, now we are creating bicycle objects. We want to keep the track of the number of bicycles we have created. And so you will realize this number cannot be changed from bicycle object to object. In other words, if we have created one bicycle, our number of bicycle count should be 1, and that is what our bicycle object 1 has. Suppose we go and create another bicycle, the bicycle 2 object, then our number of bicycles will be 2, and our bicycle 1 and bicycle 2 both should have the same number. We cannot have one value in the bicycle 1, another value in bicycle 2 when the number of bicycle count is 2. Both should have the value as 2. So now you will realize to keep this kind of information, that means information that is invariant across the objects, we cannot use our usual instance variables because they can have different values for different objects created from the same class. So the solution is to use the static variable. So now here when we create the bicycle count will be updated in the constructor, and all the objects that have been created from this class will have the same value for the number of bicycles. Now suppose someone wants to get the number of bicycles. Then for that, to return this number of bicycles attribute, we need to add a getter method, which we have here written as a get number of bicycles. And since our number of bicycles or attribute is static, our corresponding method has to be static. Another very important use of static members is when a method does not deal with any instance attributes of that class. So in other words, now if it is a method that uses this instant variable age, that method depends on the object that has been created, because that value depends on the object that has been created. However, if that method does not deal with any of such instance attributes, then we can call that method even when no object has been created. Now that is something I think I forgot to highlight here. The static methods, we can call them even without the object. Just by the class reference, we can call. So in contrast, the other methods, the instance method, for example, this getID method, if you want to call this method, you have to create an object from the bicycle. Let's say bicycle b equals new bicycle. Then we can say b.getID. However, now this get number of bicycle is a static method, which means that this method is not its values, what it does inside the method does not depend on individual object. So in that sense, since this method does not depend on any object, we can call this method even without any object. So how to call this method? We can call this method just by calling the method name bicycle. So we can say bicycle dot get number of bicycles. So again, to highlight the difference, so to call the getID method, which is not a static method, we have to first create an object of the bicycle. So we can say bicycle b equals new bicycle, and then we call b.getID. However, to call this static method, the get number of bicycles, we don't need any object. We can call it by using the class name. In other words, we can call bicycle.get number of bicycles. So this benefit is very much pronounced here. So you are very much encouraged to look at this math package in Java. So it has mostly the static methods. Why? For example, if you look at the min method in the math class. So min method, what it does is it will take two values and returns the minimum value. So if you look at if you can imagine the implementation of this min method, what would it have? It will compare the two numbers and will return the smaller number. So inside this min method, it does not use any instance variable of the math class. So which means the min method can be a static method. So when it is a static method, we don't have to create any object from the math class. We can simply call the method using the class name, as we can see here. So as you can see, it is very convenient. Otherwise, it's a complete waste of our time and memory if we have to go and unnecessarily create object when just to call a method when the method itself is not dealing with any instance variable of the class. And another important thing to highlight is this public static void main method. If you were thinking why on earth we have to use this kind of method, now it should be clear to you. Why do we have to use a static method here? Now, when you have your own program, to start the execution, the Java runtime environment has to connect itself to some place in your code. So at the very beginning, before the Java runtime environment starts executing your code, there is no object created from any of the classes in your code. So if we did not have this static method, the Java runtime environment will not be able to hook into your code because it is expecting an object to execute on. However, since with the static main method, the Java runtime environment can call this public static void main method even when there is no object from the class another here. So that is why we must have this public static void main method, and that is why this method has been made a static method. So the Java runtime environment can hook into your program even when there is no object created from your classes. So there are some rules that are applied to static members. So you may not remember this just by reading or listening to me, but when you are starting to program with these static members and all, you will, by yourself, you will learn these rules, because if you don't adhere to these rules, you will get compiler errors. And with the tooltips, you can figure out what is wrong. The first rule is the non-static data members can't be accessed in static methods. That means instance variables cannot be accessed inside the static method. Why? Because the static method might be called even when no object has been created. So if no object has been created from a class, it might mean that these instance variables or non-static data members do not have any values initialized. So it might run to error. So in order to avoid such situations, the static methods cannot access non-static data members. And the second rule is non-static methods can't be invoked in static method. That means static methods cannot call non-static methods. The reason is similar to the above. So static method, when calling the non-static method, this non-static method may have references, or maybe it is referring to non-static data members. So within the static members, when this non-static method is called, it is still executed within the static method scope. So then it will implicitly be trying to access non-static data members through the non-static method. So if the method has not been initialized because no object has been created, this again will run to an error. So because of that, this rule has been established. And this keyword cannot be used in the static method. So I think the reason is very obvious, because as we learned few minutes back, this keyword refers to the current object. But the static method may be executed in a situation where no object has been created. So there's no object to be referred by this keyword. Because of that, this keyword cannot be used. Similarly, the super keyword cannot also be used. We will learn about the super keyword in a different lecture. Another, the rules for the static methods are applied to the static initializer blocks as well. To learn what these static initializer blocks are, we will first look at the instance initializer blocks. And before learning instance initializer blocks, let's look at what these blocks are. In simple terms, block is any piece of code enclosed with curly braces. So as you can see here, we have 3 blocks here. The block belonging to the monster because it has a pair of curly braces, and the block belonging to the method style, and another block within the method style. So as you can see, a block cannot be appeared within a method, another block, or a constructor. And a block can be appeared within a class in any place. That means within a constructor, within a method, or outside any method or constructor as well. So if this block appears outside any constructor of method, we call it an instance initializer block or IIB. It is also called non-static block because it is not static, or anonymous block. It is called anonymous block because in Java you can define a block inside a class without giving any name. So that is why we call it an anonymous block. So this anonymous block is very useful to initialize variables. So variables means the instance variables, or what we call the attributes. Now you may wonder, we already have the constructors to initialize variables, but why do we have to use the instance initializer block on top of the constructors? But if you remember, we discussed in certain cases, we may have more than one constructor in a class. And sometimes some constructor may share the same code. So writing the same code in multiple constructors is a waste of time. In such a case, what we can do is the logic common to all the constructors can be moved to a IIB, or an instance initializer block. So as you can see here, this instance initializer block is a piece of code enclosed in a pair of curly brackets which appears outside a method or a constructor. And what you have to remember is, although these IIBs can be used to initialize variables, they cannot be used to as a replacement for constructor, because constructor is needed to create objects. Just because the IIB has the logic to initialize variables, that alone cannot create an object. So constructor is a must. So you must have the constructor, and if needed, you can have an IIB on top of it. And if you have multiple blocks, IIBs, they will be executed in the order that appear in the source code. That means it starts from the beginning and goes down, and the order of the blocks that appear in is the order that they are executed. Another important thing that we should remember is the variable scoping. So as you can see here, we have inside the monster class, we have now two blocks, the red block. Within it, we have the green block. So we can call the green block as a nested block. Now, as you can see, the variable A, integer variable A, has been defined in the outer block first, and then it is again defined inside the inner block. So this is wrong, because when there is a block, the variables that are defined within the outer block are within the scope for the inner block as well. So this is same for the other blocks. For example, when we define the int age at the class, within the class, this int age is applicable to the scope of all the methods. So if a method defines another int age, it is wrong. The same idea goes here. When there is a variable defined in the outer block, you can't define the same variable again in the inner block, because the outer variable is applicable to the inner block as well. Finally, the static initializer block. It is very same as the IIB. The only difference is it has a static keyword. So if you remember earlier, for this non-static block or the anonymous block or the IIB did not have any keyword in front of the block, but for the static initializer, we had the word static. Similar to the anonymous blocks that use to initialize instance variables, we can use the static initializer block to initialize static attributes. So in other words, if you, without having to write code like this, where the static variable is initialized just outside like this, we can move it to a static initializer block. Now note, this code will also work even though it does not have a static initializer block. But if you have multiple static attributes like this, the code looks more cleaner if you move all this into a static initializer block. So again, remember, having IIBs and static initializer blocks are not mandatory, but they are nice to have a better clear view of the code you have written. Now we have three places to initialize our variables: the constructor, the instance initializer block, and the static initializer block. So the execution order is first the static initializer block is executed, then the instance initializer block is executed, and finally the constructor. The idea behind this is the first static initializer block will be do initializations that are common to all objects, and then the instance initializer block will run the code that is with specific object, and constructor will run the code that is specific to the constructor. In other words, the instance initializer block will have the variable initialization common to all the constructors, but some constructors may have some special logic. So after the IIB is executed, the special constructor specific logic will also be executed. So with that, we can conclude this lecture. So today we learned how to use this keyword and its use, and we discussed the static members and IIBs and the static initializer blocks. The next week we will learn the fundamental principles or the concept of object-oriented programming.